Hi there, and welcome to another Papetti Math YouTube video tutorial where we are going to be looking at the last exercise in Chapter 4, which is on modeling systems of inequalities. So let's get right into it with exercise number 4 that says a drama production is giving away tickets as part of a promotion. Orchestra tickets are $20 each, and balcony tickets are $10 each. Just a bit of information here. Orchestra tickets are tickets that are on the floor level, and balcony tickets are obviously up a level in the balcony. So that's what it means by orchestra tickets if you did not know that part. The production wants to give away no more than 20 tickets that have a value of at most $300. Set up a system of inequalities and graph the inequalities on the grid provided. So just as we've seen this before in a word problem, the first thing I like to do is I like to group my units together. So I have $20 each, $10 each, and at most $300. So I want to put my dollars, dollars, and dollars together in the same inequality to start. So does it tell me what I need to be using for my x value and y value? And the answer is no. So I'm just going to go ahead and I'm going to write a little let statement over here since we don't know. Let x equal the number of orchestra tickets. And that means I'm going to let y equal the number of balcony tickets. So now I'm free to go set up my two inequalities. And again, keep in mind that $20 each for orchestra tickets is going to be represented by 20x because x represents orchestra tickets now. And balcony tickets are $10 each, so plus $10 per balcony ticket, y for balcony tickets. And at most 300, the very most it could be is 300. That means everything else has to be less than or equal to that 300. And there, right there is my first inequality. Now for my second inequality, they want to give away no more than 20 tickets. So the combined total of orchestra tickets and balcony tickets has to be no more than, so again, no more than 20. So we have two less than or equal to's, which is perfectly fine. And now we're going to go ahead and graph these. But before we could graph these, we have to isolate y on each one. So we're going to isolate y for 20x plus 10y is less than 300. And we're going to isolate y for x plus y is less than or equal to 20. So let's go ahead and subtract 20x over here. We should be a pro at this point because of the amount of these that we have done together. And we have 10y is less than or equal to negative 20x plus 300. We're going to divide everything by 10. And we're going to have y is less than or equal to negative 20 divided by 10 is negative 2x. 300 divided by 10 is 30. So we have negative 2x plus 30 over here. And then for this one, we're just going to subtract x on both sides, and we'll have y is less than or equal to negative x plus 20. There we go. So we have two inequalities there. And the first question we want to ask is, do we have 30 units that we could go up by so we don't have to change the scale on our axis? So let's take a look. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. No, I don't have enough. So I'm going to have to change my scaling here. And I'm going to have to go up by 2's in order to fit in the 30 units right there. So I'm going to go up by 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 22, 24, 26, 28, 30. And then I'm going to be going over by ones only. So I'll go 1, 2, 3, 4, 5, labeling every 5 lines, 6, 7, 8, 9, 10. So we can tell what we're going up by 11, 12, 13, 14, 15. And again, we want to label these axes because this is a real life problem. We know that x is the number of orchestra tickets. And over here, we're going to have the number of balcony tickets. So go ahead and label your axes as well. Probably much neater than right there. All right. So our first inequality, though, that we are graphing is y is less than or equal to negative 2x plus 30. So let's go up to 30 as our y-intercept. We're going to be going down to right 1. So now be careful there because each unit here is 2 units down right 1. So this is actually the slope of down to right 1. Given our scaling on our y-axis, that goes up by 2's. So we're going to graph all these points that fit on the plane. And we're going to connect those with a solid line because it's equal to, so it includes all those points. And again, no arrows because that we can't sell negative balcony tickets or negative orchestra tickets. But we do want to shade this, and it says where y is less than that inequality, and less than is going to be down. Okay, now that we have that first inequality graphed, we want to graph that second one that says y is less than or equal to negative x plus 20. So this one's going to have a y-intercept of 20. And it has a slope of negative 1. But remember, the slope is going down 1 over 1. But if we go down 1, we're really going down 2. So down 1 over 1 is not possible to do unless we're guessing in the middle of a line. We don't want to guess. But we can go down 2. How much would we have to go over to have it be the same as down 1 over 1? Negative 1 over 1 is the same as negative 2 over 2, because negative 2 divided by 2 is negative 1. So we could actually graph this by going down 2, right 2, 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 down 2, right 2. It sounds like a song almost. Down 2, right 2, down 2, right 2. And again, this one's going to be equal to as well. So we're going to connect these with a nice solid line, no arrows. And there is definitely going to be shading, and that shading is going to be less than. So less than is going to be downward from there. And you could start to see your intersection shaded area. And in that shaded area, you're going to denote that shaded area with a big S for solution. And those are all of the possible combinations of different amounts of tickets that the drama production could give away, where they would give away no more than 20 tickets, and the value of those 20 tickets or less would have a value of at most $300. So anything within this area right here would satisfy those constraints. Anything in here. So this video set up two inequalities in a system, isolated y for each inequality, and graphed each inequality on the grid provided. We labeled the axes, we graphed the system, we labeled the solution set, we scaled our axes. We did a whole lot of stuff with these two inequalities. And if this video was helpful in doing this, please give it a thumbs up. And you're now ready for Chapter 5. Good luck. Thank you for watching.